All right, good morning, everyone. So today we'll be working on the back end again. So we're going to be building out the rest of our stuff for our API. So first we'll talk about authentication. And so what exactly is authentication? It's the process of identifying a client. So when requests come in, you have this process called authentication that lets the server figure out exactly who made that request. It's generally followed by this thing called authorization, which is a process by which the server figures out if that person has the correct permissions to do what they want to do. So there are various number of authentication methods, from the most basic, called HTTP basic authentication, and all that is a username : password within a header called authorization. So any possible downsides people can think of about that one? If any of your requests at all get caught, then everybody has your username and password. Also, can you log out? Not really. The only way you can log out would be by changing your password. Method 2 is what's called a cookie. And this is the process by which users are tagged with a unique identifier called a cookie, and their state is stored on the server. Anybody downsides about that one? Yeah. Yeah, it's not super scalable because for every single user, you need to have something in memory that allows you to remember what that user is doing. And so with a lot of users, you need a lot of memory, and it gets a little bit inefficient that way. The last one is called tokens. And so this one, users are given an access token, which they send with every single request, and they're recognized by that token. And so token-based authentication, user receives a token upon login, and then with every single request, they send that token, just as a reminder, hey, this is who I am. I'm allowed to do this. And so the server will compare that token against what they expected the token to look like. Can anybody see any benefits over the other two that we discussed, HTTP basic and cookies? Well, for one, it's stateless. Which one of the other two were stateful? Cookies? Yeah, exactly. And so this allows, the token-based authentication allows the server to actually embed information into the token. And then you can use it with both web clients or people with mobile phones. Everybody good on the slide? So JWTs are pronounced JOTs. This stands for a JSON Web Token, and it's the most basic form of a token. What this looks like is there are three parts, each one separated by a period, where the first part is a header, so it just has some metadata that says, hey, this is what type of token it is, and here's what hashing algorithm I used to create this token. The middle part's called the payload, which is actually just JSON. JSON translated into a new language called base64, but it's just a payload of anything that the server wanted to put into the cookie. So it could include username, it could include their ID, it could include their email, whether they're an admin or not. And then lastly, there's the signature. And so how does a server know that the user didn't just say, hey, I know this middle part's the payload, let me mess with it and say I'm now an admin. And so the third part is what takes care of that. And so it ensures the token is not modified by actually hashing the first two sections against a secret that's stored only on the server. And so that way the server knows if any of it has been modified because the hashes would not match. And so all information is base64 encoded, which is just some different encoding method. Any questions on JOTs? It's a pretty simple concept. And so how do we use it? Well, there's three ways to send info to our server. Can anybody name 1, 2, 3? First one is within the body. So if you're on Express, that's rec.body. The other is within the URL parameter. So that's the URL * something equals something. And how do you access that from within Express? Anyone? rec.params. And lastly, we have within the header. And so with every single request, there exists this header, which are key value pairs, and you can put a token within there. And so which is the preferred method? It's actually the header. Can anybody give me a reason why? Yeah?
Some requests don't have a body.
Yeah, exactly. So a GET request doesn't have a body. What about a URL parameter? What's the downside there?
Not secure.
Yeah, it's more secure to not use a URL parameter because they get saved to the history. And so we are going to be using this library today called node.jot_simple, which allows us to create these jots. And so let's take a look at what that looks like. Anybody have any questions on authorization and authentication? No? Okay, we're going to go and add authorization into our application now. So if you go cd into your bootcamp directory, the coupon API will be adding jots. I pushed some stuff last night, so yes. Everybody good with merge conflicts? Everybody okay? All right, no rush. So if we want to install this node.jot_simple, how are we going to do that into our application? This one command right here. So we can go ahead and do npm install --save jot_simple so we can add it to our package.json. And now we have it. We have it installed. Oh. And so now we can go ahead and start using it. So we're going to create a new controller file called auth.js. It should already be in your directory. And this is where we're going to write a few of our authentication methods. So first we're going to take on login user. And so can anybody talk me through a basic algorithm on how we're going to do login? Any brave volunteers? Should I run coldcaller.js? All right, Brandon, I'll cold call you. How are we going to log in a user? What's our basic algorithm?
Should we, well, we're
Mhm.
somehow, if you look at the documentation, I bet you there's a way to incorporate like a post request.
Yeah, so Jot, if we look at the documentation, here's how we use it. So we have to require Jot simple into our app. We have to have some sort of payload, which is that middle part of that Jot, and then some secret that we're storing on our server. It's like a password. And then in order to encode a token, we just say our token gets jot.encode, the payload, and the secret. And so we'll definitely be using that method in order to create our token. But before we create the token, we need to make sure that the user is who they think they are, right? So first we'll have to grab the email from the user because they'll be logging in using their email and password. Then query our database, make sure that our email is in there. And then go ahead and compare the passwords before giving them a token. Does that make sense? So let's go ahead and do that. So supposedly in here, they will give us an email and a password. And so we can go ahead and check for that first. So if they don't give us a password, so if type of rec.body.email is not a string, we'll probably want to return res.status. What status should we send there? For not quite 404, because they're giving us bad input. It's not that they didn't find the login endpoint, it's bad input, which is 400. And you can send something like missing password or email. Then again with the password, if type of and so at this point, we're guaranteed that we have what we need. So the rec.body.email and rec.body.password. So we can go ahead and query our database for a user with that password or with that email. So does anybody remember how to query the database? User.find. And then what's our query object? What are we going to be querying on? Their email. And that has to match up with our rec.body.email. And then we give it a callback, which is error or user. And we first have to check what? If there's an error, then return the next error. So pass that over to our next error handling middleware. Then what should we check? Yeah, check if there's a user. So if there's no user, then we can return res.status. I'd say 400 again. There's no user with that email. And then I would say we need to check one more thing. So who's going to be logging into our coupon API? Are normal users going to be logging in? Never. So it's only going to be admin. So we can go ahead and check that as well. So if the user is not an admin and the user is not a super admin, then we should reject that request as well. So I would say we should return 403 right here, which means, hey, you found the right place, so it's not a 404. You gave me all the correct information I needed, so it's not a 400, but you're just not authorized to see this page. So 403, you're not authorized. .send, no admin with that email. All right, so now, oh yeah, question?
How can we use his admin and his secret admin?
Yeah, so this is so admin and is super admin are properties on the user that we have. And so if they don't, they're both Booleans. If neither of them exist, it means they're not an admin. And so we can just check bang user.isAdmin. And so if it doesn't exist, that would be true. And bang user.isSuperAdmin. If that doesn't exist, that would also be true, in which case they're not an admin or a superadmin, so we can reject that request. And so if they are either one, it would be included in that user that we found in the database. Yeah?
Do we have to include the Mongo, like require Mongo in this file because we're using user.find?
So question, do we need to include mongoose because we're using user.find? Answer, no, we don't, because we already included capital user up here. Good question. All right, and so how are we going to go and compare that password? We could do if user.password is equal to rec.body.password, then let them in. But that's only because we've been storing the password in plain text. Once we start hashing the passwords, we won't be able to do that. Does anybody remember that we wrote a method? Our method within user, we have user schema.methods.compare password does that for us. So that's a method that's on it's a method, that's on every single one of the user instances, so we can go ahead and use that. So we can do if not user.compare password, and what are we going to pass it? rec.body.password. Then res.return res.status. What status do we want to send here? Probably 403. 403.send what? Incorrect password. This may be 401. Let me Google for that real quick. Oh, so 403 forbidden or 401 unauthorized? Which one should that one be? There's a very subtle difference. We'll go ahead and use unauthorized, because unauthorized means, hey, we don't know if you are who you say you are because your password was not correct. Versus forbidden means, hey, we know who you are, but you're not allowed to access this page. And so they were unauthorized. And so we can go ahead and return res.status 401. All right, so at this point, we know that they are who they say they are. And so what can we go ahead and do? Anyone? Daniel, what are we going to do now?
So now we have we verified that the passwords are compared.
Mm-hmm.
Let's pull up the notes from when we were talking a while ago. So
So is the user authorized at this point?
not yet. Wait, actually. So this on line 1719, we asked them to put in a password, and we matched to what was in the database.
Mm-hmm, exactly.
Yeah, so then they would be authorized.
Yeah. So now we know that they are who they say they are. So what can we go ahead and do?
We can match. We can allow them to. I'm not sure how do we link their ID to, or the, because we have an ID in the the database, right?
Mhm.
We'd have to link their account or their. I'm not entirely sure.
All right, you're on the right track there. Catherine, you want to help him out?
Is this where we make the token?
Yeah, so now we know who they are, who they say they are, because we checked their username and password both. We know that they're either an admin or a super admin because they passed the check on line 14. And so now we can go ahead and make that token. And so how do we do that? Well, let's check the documentation. So we already did this. We require .simple, I think. Yeah. We need to create some sort of payload, and we need to create some sort of secret. And so if we're going to be using the same secret for every token, should we hard code that into this file here? No. Where should we put that? Yeah.
Does it go in the hardware? Like the secret is something that's stored on the server, right?
It could be stored on this server. Alternatively, if we wanted to store it within our application somewhere, where should we put it? In the config file. So let's go ahead and open our config file and add a secret. We can even leave a comment that says, hey, the secret for hashing tokens. So what is it going to be? It can be whatever you want. I'll just put some random stuff in.
That's too conspicuous. You should write this is not the secret to hashing.
All right. This is definitely not the secret. All right. They'll never get that one. Your secret does not have to be the same as my secret. My API is not very secure because everybody now knows my secret. But, oh well. So again, save and quit that one. And now we can go ahead and create our payload first. So var payload, what do we want to put into it? For now, let's just put all the information we have. So we can put the entire user into the payload. And then what's next? Well, we need to make the token. So I'll just copy and paste that into our code. Our token got jot.encode payload secret, but we called it config.secret. And now we have our token. And now what should we do?
Quick question.
Yeah.
This secret, is it almost like a password to access the database?
Yeah, so you can think about the secret as if it were a password to create tokens. Because does everybody know what hashing is? Like you could hash a password. So it's a one-way encryption pretty much. And so when we hash something, we give it some sort of secret to hash with. And so that secret is the secret that we're storing. So in order to generate valid tokens on our server, you need to use that particular secret in order to create those tokens. And same with verifying tokens, you need to know our secret to verify the tokens. And so you can think of the secret as if it were like a password to create and decode tokens. Yeah?
Why does it have to be secret for other people?
So question, why does it need to be secret from the rest of the world? Otherwise, if I knew the secret to the server, I could say, hey, I'm not an admin, but I know how to create a token for their server. So I could generate my own token and then access as if I were an admin. Yeah.
So I think it was our last file you had open.
Yeah, the config.
Yeah, the config. How does this token use the secret for hashing tokens? Like, so this is so can you remind me what the config file does again?
So question, what does the config file do? The config file is stored in our models directory, which means it's you can think of it as hard-coded information that we'll use other places in our application. And the reason that we're abstracting out these important information is that when we change one of these, we don't want to have to go remember exactly, hey, where did we actually use that secret? Let me go dive into my code and change these hard-coded values. If we wanted to change the secret, we could just say, hey, that's information that we would keep in the config file, so let me just go change it there. And same thing with the database URL. That's something that will probably change if we push it to production out in the real world. And so rather than remembering, hey, where did we use this? We can just say, hey, that's in the config file, let's go change it there. If we want to change what port we ran on, we can just change it in our config file. And this is especially useful if we use that information in multiple different places. Yeah, Catherine?
So the user can't see anything on the back-end server
Correct.
at all? And then on the front-end server, all they can see is like the public stuff?
Correct. So the question is, what exactly can the client see? And on our backend server, it's nothing. They can only see what we return to them. And so pretty much if we use a res.send or res.json, that's all that they can see. And on the front end side, same thing. They can only see what we send to them or what we expose to them. And so within our front end server, we had that line that was app.use express.static path.join __ dir name public, which means expose our public directory out to the world. So if they request any files, look for them in the public directory. And if they're in the public directory, go ahead and serve it as a static asset. And so the only thing that the users can see is exactly what we specify them to see, whether that be in a res.send or res.json or res.render call, or within that app.use express.static, and then giving them everything within a certain directory. Yeah.
So with cookies, you said when a user logs in, it creates a cookie for them and stores it on the server. How is that different from this?
Okay, so what's the difference exactly between a server access token and a server cookie? And so cookies, they're both similar in concept in that they're a generated unique ID pretty much for each user. The difference between the two, and the biggest difference between the two, is that cookies are stateful, whereas tokens are stateless. And so if you remember back to CS50 Finance and stuff like that, you use sessions with cookies, which means each user had a session on your server, and the server remembered exactly what the user had been doing. And so if the user requested something that was based on their last request, the server remembered, oh, hey, they made that request, let me return that information to them. Whereas tokens is purely an authentication method. From the server's perspective, if a client has a valid token, then they're authenticated. We need to authorize them to make sure that they have permission to do something, but I'm not going to remember any of their previous requests. And so in that case, I'm completely stateless. And so with cookies, it takes a lot of memory because every single user that is logged in or that has a cookie needs to, one, be remembered by the server, and two, all of their previous requests or whatever state you want to keep track of also needs to be remembered. And so that becomes a little bit of a memory hog.
What are real world uses of cookies? Like,
Yeah.
where do you see those happen?
So some real-world applications of cookies. CS50 Finance used cookies. I was digging around yesterday, and if you visit Facebook, and actually inspect the requests, let's choose this request. If you look at the headers, we actually include a cookie. And so this is the request headers. And so Facebook, since we're sending a cookie with a request, it must be the case that they use cookies. So Facebook does use cookies. Yeah.
Doesn't any sort of site where you log in and get to see like personalized information use cookies?
Not necessarily. So our site will allow you to log in and see personalized information, but we'll use authentication tokens. So being able to see information is a step that happens after both authentication and authorization. And the algorithm or the way that you go ahead and authenticate and authorize users doesn't really matter. And so even if we were using HTTP basic authentication, which just sends a username and password in the header, we can still send personalized information because we can pull that information from the database. And so that's a different step than the authorization and authentication step. Yeah.
I'm not super clear on how this is different from, like, how this is helping with login if you're just encoding one of these tokens each time they log in. Like, how is this, I guess, how is this different functionally from just, like, the password we have up above?
Meaning, like, how's this different than the HTTP basic authentication where we send the username and password with every request? I don't really understand the question.
Yeah, I guess so. I guess that's the question.
Okay, so no matter what sort of strategy we use for authentication and authorization, there needs to be one step where the user logs in and sends their username and password. Because no matter what we use, whether we use HTTP basic authentication, whether we use cookies or auth tokens, or some sort of unique one that we create, there needs to be a step where the username sends their username or some sort of identifier and their password. And so some way for us to say, hey, you are who you say you are. After that step is where these different strategies differ. And so this one, we say, hey, we're going to use our authentication tokens. And so we can say, all right, after they log in, we're just going to give them a token. And from here on out, rather than sending their username and password, they're just going to send their token. And then since we included their user within that token, once we decode the token, we can say, hey, this is their ID. This is who they say they are. Did they modify the token? Nope. So this is who they must be this person. Whereas with a cookie, once they send that login information, we'll say, hey, we'll generate them a cookie. We'll start a session for them on our server. And so that's how you are logged in now. With HTTP basic authentication, you don't really need a login because all you're doing is sending your username and password with every single request. And so you can just start making requests. The downside to that is you can't ever log out. And if any of your requests are stolen or read, then they have your username and password. Does that answer your question? Awesome. Any other questions about this stuff? No? Can anybody tell me what our next step would be in our login function over here? So we made sure that they had a username and password. We went and found the username by the email, rejected anybody who's not an admin. We compared their password, it matched, so at that point we are fairly certain that they are who they say they are. And then we went and created a token. What's all that's left to do? Redirect them is almost correct. So right now we're on our backend server. So remember, we always respond with peer data. We don't redirect them to a different page or anything. That would be front end. So you want to update your answer? Sure, you want to help them out? Do you know?
Do you need to store the token in the backend so you can compare it again every time it comes back?
So the question is, should we store the token in our database? My answer is probably, and we will get to that step in a little bit later, but we'll go ahead and stop or omit that for now. If we were not going to store our tokens, what would we do now? Anybody know? Yeah, just return not 200, but we want to return the token itself. That way they can go ahead and start using the token. So we can do res.json. What do we want to send? We can send the token. All right. So let's go ahead and expose this function to the world. So how are we going to go ahead and do that? Anybody know? How are we going to access this function? Yeah, so we need to do module.exports, which exports.login user would do that. And so now this is exportable. Where are we going to import it to? wherever our routes are, right? So let's go ahead and find our route. So this is in our main server file, couponapi.js. And so we can go ahead and require that file in. So we have const users gets required controllers users coupons, and now we can do const auth gets require controllers auth. So now what? We now required that function, that whole module, into our main server file. So what do we have to do now? Anyone know? Oh?
Should we add it to our routes?
Yeah, we need to add it to our routes, exactly. So let's add it to our routes. Anybody want to suggest a route we should use? Is that hand?
Like posting your information when you submit the form to log in.
Yeah, that would work. So we'll do a post. Anybody want to suggest an endpoint? I generally go with /auth/token, but that's just personal preference. All right, and now we can go ahead and test this. So have a syntax error. So this is an error that I saw a few of you guys getting. Does anybody remember what it does? What it means? It means I used that app.get function, and rather than passing an actual function, I accidentally passed it something that was undefined. So this is at line 41 of that coupon API file. So let me go see what's happening there. Line 41, users.getUsers. Did I change the name of that? No, get all users. So that's a little insight into the debugging process. So I had to figure out exactly what they were complaining about first. So had to parse through this error, had to go find the error. And so reading through this call stack, I see that this is probably the line that threw the error. And so I went into that coupon API file, line 41, and found that, hey, I actually wrote down the wrong function name.
So what did you change it?
So I changed the controller file from exports.getAllUsers to exports.getUsers, because getUsers was the function name that I specified in the main server file. All right, everybody with us? So no users in our database right now, so we should go ahead and add a user. And so how are we going to add a user? We can use that endpoint that we created, so post to users. So we should probably give an email. So we can use my personal email. We need to give it a password. We need to say, is admin, it's true. And I'll make myself a super admin too. So go ahead and send that. Oh, need to include a phone. And now I'm in that database. I can verify. Oh, there I am. My hash there in plain text, so we should probably go back and fix that. But let's now try our login endpoint that we created. So we can go ahead and make a post request to what was the endpoint? Does anybody remember? As auth/token. Our body. This will work. All right, cross your fingers. 403, no admin with that email. Oh, is admin did not get saved. And so we have a bug somewhere else in our application. Where might that be? We could check the schema. We could also check the controller file. So first, let's check the schema. So nowhere within here do we actually mess with isAdmin, so it must be in the controller file. So let's now check the controller file. So does anybody spot the bug? So we created this new object called user data and started filling that up with all of the requests, the request body. But nowhere within here do we ever touch isAdmin. And so I actually went and created a separate controller file where we create an admin. And so it does the exact same thing, but it also checks for isAdmin and is superadmin. Does anybody see why I might have done that? So when you create a user, do you need any authentication to create a user? No, right? Because people can just go sign up wherever they want. But what if somebody who knows a little bit about how the internet works goes to our website, says, hey, this is the endpoint that they're sending to in order to create a user. Let me just try to make myself an admin, and threw isAdmin true into their request. We would have just added them as an admin. And so I made the call, hey, maybe I'll just create a separate endpoint called create admin, and only that endpoint can add admins. And so we need to expose this to the world as well. And so now I have another controller file. And so now within our REST organization, it seems like we have a whole new object where we can create admins. Yeah. Does everybody follow my logic why I might have done that?
How is it like more secure though? Can a malicious user still just like hit the admin's endpoint, or is that just...
Yeah, exactly. So question, why is this more secure? Can't they just say, hey, let me see if they have a /admins endpoint? And the answer is yeah, absolutely. Right now it's equally insecure. But we will be writing authorization like functions that make sure people are admins before they are allowed to post to these certain endpoints. And we'll add some authorization to that particular endpoint. All right, so now let's restart our server. You'll have to run npm install save bcrypt-node.js. And then rerun. So bcrypt-node.js. And I'll show you exactly what that is in a few minutes. And so now let's try to create the admin again. So let me delete myself first. And now let me post to admins instead. And so in that admin's endpoint, I also mandated that you need something called a company name, which I thought would be useful to display with each coupon. And so I had to go ahead and add that to my request. Was everybody able to successfully add themselves to their database? Is anybody getting errors? Which error is it?
Oh, I don't know. It's some weird like MongoDB there.
Yeah, I'm getting the same.
What is it saying?
It's saying trying to open unclosed connection.
Just run kill all MongoD and then restart your server.
Can you show us your post request in the coupon API.js for the authentication?
This?
Yeah.
Did that error get fixed?
No, I tried that before and it's still...
Delete everything in there. I'm just going to delete the lock file. I'll look at it a little bit later, but just follow along for now. All right, if people are getting weird MongoDB errors, just ignore it for now and follow along, and then I'll help you during the hack session. But now we were able to add ourselves to the database. So let's verify that by getting the users. And I'm in there. I am a super admin and an admin. And you see that my password actually got hashed because I had included that code in admins.js. But we'll go ahead and add it to our schema in a little bit. There's going to be a little bug that I foresee. So let me just paste this as my password. And so because the endpoint that we wrote only checks the password in plain text, I'll actually have to use my hashed password as my plain text password when I log in. But let's try to now get a token. No admin with that email. So we have a bug somewhere in our controller file. So let's try to track it down. So I'm just adding a console log so that it allows me to see exactly what that user is to make sure, because it's not sending no user with that email, it's sending no admin with that email, which means we found a user. So let me see exactly what they think that user is. Let's try to create that token again. No admin with that email. And it is printing is admin is true and is super admin is true. So we have some sort of bug over here. Does anybody see the bug? Because I don't. Let me see exactly what they think is admin is. It's printing out true and true. So not true is true apparently.
How did you put true into when you request when we put into Postman?
I just put it in as a Boolean. I said a Boolean here, and it got saved as a true Boolean because it's not wrapped by strings. So why is not true true? Undefined. Okay. So, oh, I know what we did. So by doing user.find, what does that return to us? It turns a list. Yeah, so it returns an array. And so what we should have done is user.find1, which returns exactly one user, the first user that matches. And since we specified that email has to be unique, then there only will be one at max. So that was our bug. So right now, when we do users.find or user.find, that returns an array of everything that matches. And so that's why when we console.logged, it's actually an array with one object in it. And so that was our bug. And so we console.logged around until we eventually figured out, oh, that must be our bug. And so our options are either use user.find1, which will find that first instance. And since email is unique, that's totally fine because we'll find either 1 or 0. Or we could have just had our next line be var user is users bracket 0 and change this to users. So they would have done the same thing. Let's just take the simpler route and use user.find1. And so now we can delete these console logs, and we should be good to go. So you can go ahead and try to get a token again, and now we got our token. So does anybody have any questions about the debugging process? You've seen me run through a few of my debugging strategies. So throwing console.logs in, inspecting these things, looking at the call stack, parsing errors. Does anybody have any other questions about the debugging process and how we could go about in doing that? No, it's just find the bug.
Hey, Jordan.
Yeah.
What is the npm debug log? Like,
Oh, so if npm throws errors, then it will log those to a file as well. And so that's that npm debug.log file. All right, so we got our token. Is anybody interested in how this token actually looks? So we have something, a dot, a bigger something, a dot, and then something. Does anybody remember what those three parts are? We have our header, which says what kind of token is this, what hashing algorithm are we using. We have the payload, which is everything that we wanted to include, all that information. And we have the signing, the hashed part to verify the token. So let's actually play with this token a little bit. Let's cut and paste this first part. And let's just Google around for a base64 decode. Find the first one and just paste that first part of the token in there. And it actually decodes into this plain text that says type jot algorithm HS256. And so that is the header of our jot. If you're curious what the payload looks like, we can cut and paste this. And look, there's our user. And so it's actually, jots are actually just embedded information. And so when we send our token, our front end could decode this jot if it wanted and find out information about the user or find out any information that we wanted to give it. Cool, so let's go ahead and add a couple more things. So Shira made the recommendation that we should save that token into our database, which is a good idea. Every time the user generates a new token, we should store their most recent token so that if somebody stole their old token, they wouldn't be able to log in with it. And so let's go ahead and do that. And so what we have to change in order to start saving our tokens. The schema. So let's edit our schema. We'll have to add one more thing, token string, which I already put in there. And so now what else do we have to modify? That controller file. So right before we send the token, we should probably save the token with our user. And so how do we do that? Does anybody have any ideas? Just a couple lines. So user.token should be that token. which means, hey, assign to that property of users called token, the token that we just generated, and then we should save it. So user.save, which takes a callback with a single error. We should check if there's an error. And then within the callback, we can go ahead and return that token. Does anybody foresee any bugs? It's a little bit of a funny one. Let's see what happens. So save this and restart our file, our server. And then let's go ahead and relog in. So we got a token. And did it save our token? Let's check. Yep, there it is. There's our token. Let's now create another token. Oh, our token just got a little longer. Let's create another token. Oh, wow, our token's pretty long now. Does anybody know what's happening? Yeah. Yeah, exactly. So every time we generate a new token, it gets longer because it embeds that token into the token itself. And so because we're storing the token itself, or the last token, in the auth token, the next auth token, they just keep getting longer and longer and longer, and before you know it, you have a 20 kilobyte token, which requires lots of scrolling. So that's probably bad design. What should we change? Yeah, we should change the payload. So let's not include the entire user into our payload. And let's only include the relevant information. And so we'll probably want to pass the ID. So an ID gets user.underscore ID is just the default name of that property for Mongo. What else should we store? Maybe the email? I said company name as well. Company. And that's what I arbitrarily called my payload. And now if we save that and restart our server. Okay, short tokens, we're good. If you notice, is my token changing at all every time I get a new one? No. So this limitation of this Jot simple library is that it's the minimal that you need in order to create a token. And so it doesn't include with it any expiration dates. It doesn't include anything like that. And so if you wanted to use more advanced tokens, you might consider using a different tokenize module, but this is fine for now. You can also implement things like expiration manually, but I'll leave that up to you if you want to do that later on. All right, and so now what else should we add? We should probably hash every user's password, right? So how are we going to do that? So we foreshadowed it a little bit earlier this lecture, but there's this thing called Bcrypt, which is the go-to library for hashing anything. And so if you look at the usage, you have var hash gets bcrypt.hashsync something, compare sync, which is the synchronous usage. There's also an asynchronous usage where you can tell it to hash something and it'll pass it within the callback. So let's go ahead and add this library to our schema. All right, so what do we have to do in order to require this library? Well, I just gave you the answer. You got to require the library. And so how do we now use this? So it says in order to hash something, we need to do bcrypt.hash sync and then just pass it a string, and then it'll do it synchronously. So let's go ahead and use the synchronous one. And so we can now check off this to do. So to do hash, we can do if this dot. I'm going to use this thing called isModified. So this dot isModified and pass it the hash, because we don't want to rehash a hash if we're updating something else. So remember, this user schema.presave will get executed every single time we try to save the user. And if you remember, every time the user logs in, we save again with the token, a new token. And so we don't want to rehash the hash if it's already hashed. So we'll go ahead and only hash the hash if it's modified. And so there's this thing called isModified, which is built into Mongoose, and it'll tell you if it was modified or not. And so if it was, we can go ahead and hash it. So let's do this.hash gets bcrypt .hash sync. The old hash. All right, so we now successfully have hashed all passwords when they're getting saved. Now what do we have to also update? The compare password method. And so let's go ahead and use the asynchronous one for this one. So we can do bcrypt.compare. We pass it a string, we pass it the hash, and it gives us a function that has an error if there's an error, otherwise the result, which is a Boolean. So let's go ahead and copy and paste this directly into here. And so what do we want to compare? Well, we want to compare the first argument, the password that was passed in. We want to compare this.hash, right? And then always do our error checking. We also need to pass this a next if we want to invoke next on it. And then we're going to do this weird thing. This is us now coding in an asynchronous manner. So we're going to invoke next with null and the result. And if you want to use better variable names, we can rename result to isMatch, which is what we pass down here. And we can change the name of next to callback if desired. All right, so we just wrote our first asynchronous method. So this method is a function which we need to pass a password and we need to pass it a callback. And then what does it do? It compares the password using Bcrypt's asynchronous compare password function, its method. We pass it that password, this.hash, and its callback gives back an error and isMatch. And then we invoke our own callback. So if there's an error, we'll return callback with error as the first argument. Otherwise, we'll invoke callback with the first argument being null, meaning there was no error, and the second argument being isMatch, that Boolean. And so now we can go ahead and update our controller. Within that auth.js folder, or that auth.js file within our controllers. And rather than doing if bang user.compare password, we need to now do it asynchronously. All right, so on the bottom we have our method, and at the top let's actually go ahead and use our method. So we can no longer do it synchronously because we chose to do it asynchronously for practice. And so now let's, rather than doing this synchronously, let's do it asynchronously. So we'll have user.compare password. What arguments does it take? The password, which will be rec.body.password, and a callback, which takes two arguments. The first one being an error if there's an error, and the second one being isMatch. And so we can go ahead and say our callback function takes two arguments, an error if there's an error, and isMatch. And so first we have to check if there's an error. So if there was an error, return next error. Then if the passwords didn't match, so if not isMatch, then return this thing up here. And then now we're at the same point logically as we were before, so everything else can just follow. And just tab it in so that it works. And then now we're done. So a little bit mind-bending using asynchronous calls for the first time, but does everybody see what we did? Any questions on this asynchronous call? It's a little bit confusing, but we actually asked for our own callback for the first time. Can everybody follow the logic?
Could you go through it one more time?
Yeah, absolutely. So we wrote our first asynchronous method, which is used to compare passwords, and what it does is it takes it's a function that takes two arguments. The first one being the password that we're comparing against, and the second one being a callback. And so we have to actually use this bcrypt.compare method because now that we're hashing our passwords, we can no longer just say, oh, is the password match what we have in our database? And so bcrypt gives us this method called compare, which will asynchronously compare the password against its hash. Since it's asynchronous, it takes a function as a callback, or it takes a callback as one of its function parameters. And that function takes two arguments, error and isMatch. And that we only know because it shows us in their docs. And so now we have two callbacks to keep track of. One callback from bcrypt.compare, and one is the one that we're asking for within our function. And so first we need to check if there's an error. If there's an error within bcrypt compare, we pass that as the first argument to our own callback. Which means, hey, when we actually use this method, we'll use it exactly like, we set it up exactly like all the other methods from Mongoose and from Bcrypt for another example, where error is the first argument if there is one. So we can run this return callback error. And if there wasn't an error, that means they passed isMatch back to us. And we're going to pass our own callback, null as the first argument. Why are we passing null as its first argument? Yeah, because there's no error, so null means absence of. There's an absence of an error. And the second argument is whether it was a match or not. And so when we go ahead and use this user.comparePassword, we're passing it first a password, which is what it was asking for here. Second, a callback. How do we know what arguments the callback takes? Well, we wrote it. It takes two callbacks, one an error if it occurs, and second is whether it was a match or not. And so we can go ahead and use that function. First argument is an error if it occurred. Second argument is a match. Check if there's an error. And if there was no error, this would be null. Therefore, this would not be a truthy value. Otherwise, we can go ahead and use isMatch as if it was a Boolean, because we know it will be. Does that make sense to everybody? It's a little bit mind-bending writing our first asynchronous function, but definitely something very important. And then again, we're now at the same point logically as we were before with our asynchronous call, which we can now delete. And so we can go ahead and create the payload, create the token, send the token, and then close our function. So we now just updated our compare password. So now we are hashing all of our passwords upon creation. So let's go ahead and test that. Let's get all of our users and go ahead and delete me. So now no users. And now let's create a new user. So you can reuse that post that we did before. To admins. Oh, let's do it to users. Oh, users don't get passwords. Well, we can test this by actually testing our compare method by trying to log in. And so now I have to recreate myself. And now I can try to log in using my actual password. All right, moment of truth. And we got our token. Any questions about hashing, asynchronicity, authentication? All right, so one more thing that we didn't get to do yet is actually authenticating a user now, and so checking their token. And so what I think I'll do is I'll just push code that works and allow you in your partners to read through my code, understand it, ask any questions if you want, and then start applying these, rewriting these for your own projects, for your dorm supplies API. Does that work? Does everybody remember their groups for the front end or for the back end? Do you want to re-roll? We can just re-roll if you want. All right, let's re-roll. So here are partners for today. Can you read? Want me to just read out loud? Joey and Ho, Dong and Daniel, Barty and Akshitha, Ethan Chiang, Brandon Catherine, Jeremy Haley, Allison Shira, Avraj Josh, Gerardo Alex, Tiffany Jason, Samir Galen, Will and Jeffrey. So go ahead and break off into your groups for back, and then you'll be working on that dorm supplies backend and adding authentication, adding hashing for your passwords, and if you get to it, adding actual authentication for endpoints.